All right, in video 2, we're going to talk about question 19. So let's take a look. A car dealership looked back at the previous year's sales, and last year they sold 422 vehicles. The mean price was $24,500, and the standard deviation was $12,875. The dealership also discovered the distribution was skewed right. So you might be thinking, oh, interesting. So it's skewed right, and oftentimes data sets are skewed right. And so if they put this data, the 422, they're noticing that it looks like this. So somehow the mean is 24,500, and the standard deviation, a typical amount that they vary from that, is around 12,875. Now, I normally like to use my samples, but this is actually all my data set. This is my entire data set. And so even though it rarely happens, they actually gave me the standard deviation of my entire data set, right? And they gave me MEO. Pretty cool, right? So now, this is actually my population data. So in my population is 422. Okay. This is my population distribution picture here, something right skew like. And so if we were actually to take random samples of 40 from these, so that's why little n is 40, then we actually like that. We're like, oh, that's even though this is not normal, we actually know that the sample, if we took 40 samples from this data, we actually know it'll look relatively normal because of the central limit theorem. The central limit theorem states that as long as n is greater than or equal to 30, and since 40 is greater than or equal to 30, then it will be the distribution of the sampling distribution will be approximately normal. Okay, cool, right? So, well, what will be the mean of this data? Well, the mean doesn't change. If the average price of this data, and this is where we're pulling the data from, that shouldn't change, so it should stay the same. So hopefully you're selecting these two and you crossed these out. And then what would be the standard deviation? Well, the standard deviation of this, not sigma, but the standard deviation of your sample. So your S of X, right, would be sigma over the square root of n. So that's where we're getting this value. Your sample size. Awesome. Okay, and this is how our calculators work, and this is why these stat tests work. Good question. All right, let's take a look at question number 20. It says, the speed of a pickup of a ride share like Uber and Lyft seem to have surpassed ambulance services. So what they're saying is if the mean response time of an ambulance, so if the mean response time of an ambulance, right, is this, and the standard deviation of the ambulance is that, for ride sharing, if it's something other than that, right, so the mean pickup time is for ride sharing is, I'll call it R, ride sharing is 8, and sigma, the standard deviation of that ride sharing. Based on these estimates, which of the following would give the standard deviation of the sampling distribution for the difference if the sample mean was 30 and the ride sharing was 40? Okay, so this is your basic formula. You're essentially using the standard deviation of the difference is adding the variances of these two. And so technically the variance is the standard deviation squared. So whether you're using sigma or S, the variance here would be that would be the variance of the first one, and this would be the variance of the second one. And notice when you square it, it simplifies this, and that's where the square root falls off of the bottom. And then we have to add variances, and that would equal the variance of the difference. But we don't want the variance of the difference. We want the standard deviation. So variance is actually standard deviation squared, which is why they asked you to take the square root of the whole thing. All right, that's essentially the concept and why that's the correct answer. Okay, 21, a poll was conducted using samples of 2,500 to determine the proportion, so it's a proportion question, of voters who plan to vote for the incumbent president in the election. The pollster said, we are 95% confident that the interval from, that the true proportion is the interval from blank to blank. What is meant by this? Okay, now this is going to be on your test, but it won't be multiple choice. So this is exactly how they can take a normal free response and beef it up. They can actually ask you to create one of these, and then as a follow-up question, a beefier question, they can ask you and interpret what that means in the context. So we have to be ready for this. I would put money that this is going to be on your test. So we need to be able to have the right words. So when they ask us to interpret it, when they ask us to conclude, we write that right there. That's what we write. So if they ask us to conclude, we write this, right? We're 95% confident that the interval from blank to blank captures the true proportion. But when they then ask us to interpret what it means, we must write this. If we select many, many random samples of the same size from the sample proportion, and we were to construct a 95% confidence interval using each sample, then about 95% of the intervals would capture the truth. So we are essentially not saying any of these are the truth. And that's what's wrong with a lot of these choices. We're not saying that this is the truth. We're saying we believe that about 95% of the time, if we created intervals, we would capture the truth. So we don't even know what the truth is. We just think it's somewhere between there. And that's how confident we are in that interval we created. Okay. Let's take a look at 22. Okay, this reminds me of some notes I took the other day. So it says a recent study of rovers surveyed a random sample of 1,500 dogs. Okay. And so that's where that number came up in our answer. The research revealed that 975 dogs admitted to taking more photos of their dogs than the significant other. So where does that number come up? That's what created our test statistic, 975. That's how many said yes out of the 1,500 we asked. Okay, which of the following gives you a 95% confidence interval? So how is a confidence interval made up? You're not going to get a question like this in multiple choice. You're actually going to be asked to actually do this. So that's what's more important to me. So if you were actually to do this, you would know that you should be grabbing an critical value of 1.96, and here's the standard error of the statistic. But how would you do that on the calculator? So let's take a look. First, you would state, plan, do, and conclude. So step one, state what it is you're going to do. So I will perform one proportion Z. I only have one proportion, right? And proportion tests are Z. So how many said yes? Well, we know that 975 said yes out of the 1,500, and we're going to leave the confidence interval at 0.95. So that's how these numbers get calculated, and this is more accurately how you'll be tested on this material, not in a multiple choice question. Okay. So you would need to say we are 95% confident that the interval from 0.63 to 0.67 captures the true proportion of all dog owners that would admit to taking more photos of their dog than their significant other. Okay. You also would have to show your interval, right? But if you did that summary, you would have done that anyway. You also would have had to check your conditions. So you do your random. You would say the population of all dog owners. needs to be at least as greater than 10 times our sample size, right? And you have to do large counts. So that means at least 10 yeses and nos. So you've got, yeah, plenty of yeses. That's more than 10. And then if you subtract that number, that's like greater than 500. Yeah. So you got more than 10 nos. So your conditions have been met. So you should be prepared to answer this question, not as a multiple choice, but as a free response. Let's take a look at 23. Now it says, cat lovers claim that cats are just as smart as dogs. So they did a study, 4 dogs, 4 cats, and created a confidence interval between the two. So let's take a look. When they created it, they got an interval when they took the proportion of dogs minus cats that were able to be trained to take on the skill. Notice these are the plausible values of the differences between dogs and cats who can roll over. That was the trick they were trying to tell them. So notice, think about this for a minute. If 35% of the cats rolled over and 35% of the dogs rolled over, then if zero's within there, then we actually have some plausible evidence that there is no difference between whether a dog or a cat is or isn't more trainable. So that's why this answer is correct. If we think about this from a significant test standpoint, it's the same thing as saying we do not have sufficient evidence that there is a difference, okay? We wanted to say that there is a difference because cat lovers were trying to say they were just as smart. But we don't, or more smart, but we don't have evidence to say that there is a difference. And that's what we set out to do. Check out the next video for the next questions.